Good morning. Happy Monday. Hope everybody's ready for some math. Good morning, good morning. Good morning. Oh. Good morning. Trying to post. Good morning. Make sure you all know where we are. Good morning. Make sure you're ready to finish day one from week 5. Good morning. Hope everybody had a great weekend. Hope you thanked your mothers and grandmothers and stepmothers and sisters and teachers and everyone who serves as a mother to you on Mother's Day. I hope you thanked them all. Good morning. Good morning. I'm going to flip this around so you can see. This is the lesson we started with last week. We're still a couple minutes early. Good morning. I know people were finishing the community meeting with Dr. Armstrong and Mr. Williams. It was good to see you guys on there. Good morning. Don't forget Monday mornings at 9:45 is community meeting. So they give you lots of information and support. If you did advisory this morning, please make sure that you're thanking all of the people in the building that support you. Good morning, dear. Good morning. Make sure that you're supporting the deans and your social workers and people that give you lots of additional support besides, the teachers and administrators. So this is your week to thank Mr. Williams and Ms. Harvey and all of the people that support us on the 6th grade team besides academically. So good morning, dear. It's good to see everybody. The numbers are going up. Good. Everybody should be logging in. You can always send the little message to your friends with that little paper airplane sign at the bottom. Remind them that we're here. We do Mondays and Wednesdays at 10 o'clock. This is day 1 of volume with fractional edges that we started last week. We did this last Wednesday. Excuse me, so it's 10:01. I'm going to just go over it a little bit to remind you. You guys had already done the do now last week. You're supposed to DM me the pictures of that before class to get your credit. Then we started with new learning. We did this on Wednesday. It was reminding you that in 5th grade, you had already learned how to calculate the volume of a rectangular prism. Okay, that's something that has a base that's a rectangle, and they add volume to it. So it's not an irregular shape, it's just a rectangle that has volume. That's why they call it a rectangular prism. So they were reminding you that you had already learned, good morning, how to calculate volume using the typical volume formula, which was the length, good morning, times the width, times the height. Okay, so if you missed on Wednesday, this is what we went over. And it was already in your packet. I had said in the assignment, good morning, to make sure that you read the new learning. Okay, the new learning is always the notes and what we're going to be going over. So again, we're just reviewing really quickly what we started on Wednesday. Excuse me, before I go through a couple problems. Okay, so this was a review of the formula you learned in 5th grade. And geometry is often a unit at the end of the year in 5th grade. It's often after Park. So you may not have gotten through the whole unit. Some of you may not have learned this in 5th grade. But what it meant was to take the volume of a rectangular prism, you would take your length times your width, just like you would for a rectangle. But this time for volume, you'd also multiply it by the height. Okay, so we did this on Wednesday. We went over, we reminded ourselves how to get these mixed numbers into improper fractions, where we take the whole number and multiply it by the denominator and then add the numerator. and do it over the same denominator. So 2 times 6 would be 12, plus 1 is 13, and this would be 13 halves, 13 over 2, times this one, which would be 2 times 4 is 8, plus 1 is 9/4, and that's where they got this. Okay? And we did all of these steps the other day. I walked you through. Then they talked about how when you already have the area of one side of the rectangular prism, you can use that formula instead. I'm trying to find that part to remind you. So what we were saying was, if you already had the area of one of the rectangles of your rectangular prism, that's called the area of the base, and then you just take that and multiply that times the height. So that was the other formula, and we said that's represented with the capital B. Okay, so that was a review of what we did the other day. So these were the two formulas. We had volume equals length times width times height. Good morning, good morning. And then we had volume is the area of the base times the height. Okay, and I even broke down for you that all the B was doing was taking the place of the length times the width, right? Because length times width is area. Before we got into volume, we learned area. That was a precursor step, and even probably in 4th grade, you did area of rectangles a little bit. Okay, so that's our review of what we did. There were some, again, we said that, the problems in 6th grade take it to a new level because, even though you may have learned the formula in 5th grade, now we were doing edges that had fractional measurements, okay? And again, we reviewed how to get from a mixed number to an improper fraction, and then we multiplied these, and then we did our long division to get the answers. We also reviewed the other day that when you have an area, that's meters squared, right? Anything that's just meters is just a simple length or distance. When it has meters squared, we said that demonstrates that you're doing area. And when you have meters squared times meters, you get meters cubed. And we talked about how meters cubed is a symbol that you're assigned to you that you're doing calculating volume. Okay? It's meters cubed because you're multiplying three things together. You're multiplying a measurement of length and a measurement of width and a measurement of height. So if there's three things you're multiplying, then you're going to have the meters be to the third. For area, where it's just, length times width, that's why meters is meters squared. Because you're only multiplying two things, two sides. Excuse me. So today we're going to be using this area of the base times the height. Again, I just wrote it down there where we derived that from. And we're going to use that today to go over the problems. So your assignment was to go over number 1. Okay, and they had given you a lot of information about how to solve it. The two different ways that they talked about. One way was doing length times width times height, just using the picture, the measurements from your picture. The other one was breaking down how many quarter meter cubes would fit on each side. Basically taking each length and dividing it by a quarter, and then multiplying those three measurements together. And so we did that example. We did an example of that on Wednesday. And so you were going to do number 1 and number 2. Good morning. Okay, you were going to do that, number 1 and 2, for your assignment. So you'll just take pictures of the work you showed for those and DM that to me. We are going to work on, I believe this is number 3 on your paper. I don't know if it's numbered 2 or 3. I think they've numbered 2 things, number 2. But this is what we're going to do now then, is we're going to use the rectangular prism to answer the following questions. They've given you a picture of a rectangular prism, okay, just like they would on an assignment or a test, okay? They have a comment they've added that in this rectangular prism, the length is 8 centimeters. Okay, we talked about the longest side is usually our length. There's a shorter side, which would be a width of 1 centimeter, and then a height of 1.5 centimeters. Okay? Then they've given us a table to fill out. Okay? So, what we're going to do is, we're going to see what happens. It says complete the table to see what happens when the length changes, but the other dimensions remain the same. So what they want us to do, it's kind of an exploration, is we're going to keep changing this length. Excuse me. We're going to keep these two numbers the same. We're going to keep the same width and the same height. And we're going to see what happens to the volume of the whole shape if you only changed the length. Okay? So, we're going to walk through it line by line. So, again, you've already read through this as part of your assignment the other day when you had to read Good Morning. Excuse me, today I have a real tickle in my throat. Hopefully it's just a tickle. So, I'm trying to keep a little bit of the picture up, but you'll have it on your whole paper. So, when the length of this shape is 8 centimeters, okay, that's in the table, they got a volume that the whole rectangular prism is 12 centimeters cubed. Okay? So, just a reminder of how they did that. Okay? They had volume equals length times width times height. There's a length of 8, a width of 1, and a height of 1.5. So my 1.5 I have to change into an improper fraction. So 1 times 2 is 2, plus 1 is 3. So I would have 3 halves. Now, to make it easier to multiply fractions, we've always talked about any number by itself, any whole number has a denominator of 1. That's one of the invisible ones we talk about. And that makes it easier to multiply your fractions, because as you learned in 5th grade when you multiply fractions, and we reviewed in 6th grade, you're just multiplying numerator times numerator times numerator, and then denominator times denominator times denominator. So 8 times 1 is 8. 8 times 3 is 24. 1 times 1 is 1. 1 times 2 is 2. What is 24 divided by 2? You can type it in the comments. What is 24 divided by 2? Go ahead and type it in the comments. Hello, hello. Type it in the comments so you get your participation points. What's 24 divided by 2? Thank you. So 12, okay? And if we had centimeters times centimeters times centimeters, I didn't write the units, then I'd have my centimeters cubed. So that's where they got this volume, okay? Now, they're saying, well, what happens if you take 1/2 times the length? Okay, so 1/2 times the length of 8. So 1/2 times 8, that's where they got 4. And they want to see what happens to the volume. So this time, if we had a length of 4 times 1 times 3 halves, and I'm going to write it the same way, then I would have 4 times 1 is 4. 4 times 3 is 12. 1 times 1 is 1. 1 times 2 is 2. What's 12 divided by 2? Go ahead and type it in the comments. Come on, these are easy multiplications and divisions. Excuse me. We're simply just multiplying numerators times numerators, denominators times denominators. 12 divided by 2. Thank you. We'd have 6 centimeters cubed. Okay, so in your box, where it says if the length of the prism, if this length was changed from 8, it was cut in half, half times the length is 4. Excuse me. Then you would get 6. Okay? If you have any questions, make sure you put them in the box. Now we have 1/3 times the length. Okay? So, we have 1/3. And just to remind you, it's 1/3 of 8. That gives me 8/3. I don't need to divide the 8 by 3 yet because I still have more calculations. So, 1/3 times 8, L is 8. 1/3 times 8, remember that's how we get 8/3. Thank you for asking. Yeah, hopefully I just have a little tickle. So, we have 8/3 is our length times our width is still 1/1. Our height hasn't changed. It's 3/2. Remember, we said all we were going to do was be changing the length. We weren't going to change the width or the height. So that's why I keep using the 1 and the 3/2. 1/1 and 3/2 as my width and height. Because I have length times width times height. Now, we're going to remind ourselves one of the ways we had to reduce within a problem to make it an equivalent fraction was to reduce it before we multiplied or divided. So there's some things in here that we can cancel out. And if we divide this 3 out, 3 divided by 3 is 1. 3 divided by 3 is 1. That makes it a little easier. I'll just keep multiplying then. 8 times 1 is 8. And 8 times 1 is still 8. 1 times 1 is 1. 1 times 2 is 2. What do you get if you have 8 divided by 2? Go ahead and type your answer in the comments. 8 divided by 2. And we still have centimeters times centimeters times centimeters. Good. We'd have 4 centimeters cubed. Okay. Does everybody see where that came from? Now, you could have done the reduction even before I was outside. I could have done the same thing here. Remember, you're looking for common factors, the greatest common factor when you do these reductions. So 2 would have gone into 2 once, and 2 would have gone into 8 4 times, and I would have had 4 times 1 times 1, which would have been 4, and 1 times 1 times 1, which would have been 1, and 4 divided by 1 would give me 4. So you could do it both ways. I was just trying to show you a quickie way, especially when you're doing standardized testing like PARC and unit tests, that makes it a little faster, because sometimes finding all the ways to reduce inside of a problem isn't the most efficient way. Okay, so now we have 1/4. So we filled out this table, right? They already had that answer, so we know we did it correctly because we got the same answer as they did. Okay, and they're just reminding you when you're calculating the volumes in the table, we're just changing the length, and the width and the height are staying the same. So now we're on the next one, which is 1/4 times the length. So that's 1/4 times 8, right? 1 times 8 is 8. 4 times 1 is 4. What's 8 divided by 4? Good morning. Good morning. What's 8 divided by 4? Again, I'm just showing you the work so it's transparent to everybody where these numbers are coming from. Some of you could say, oh, 1/4 of 8, you already know in your head it's 2. But remember, we want to be able to justify our answers and show the evidence of where we got those answers. Great. So I'm still just on the part where I'm finding 1/4 times the length of 8. So all I'm doing is filling out this length of the prism. So my length right now is 2. So I'm going to make it a fraction by putting it over a 1. So that's my length. 1/1 is my width. 3/2 is my height. Right? And there's a couple ways I could do it. I could divide out my 2's before I multiply, or these are simple enough, 2 times 1 is 2, 2 times 3 is 6, 1 times 1 is 1, 1 times 2 is 2. What's 6 divided by 2? 6 divided by 2, you can just type it into the comments. 6 divided by 2, 6 divided by 2. Yeah, it's not very taxing for a 6th grader to do 6 divided by 2. I think you all have some siblings that could do that one. Thank you. So that's 3 centimeters cubed. Thank you. Thank you. Thank you. Okay. So, you can see that changes are happening. Good morning. Good morning. As I'm changing the length, from 8 to 4 to 8/3 to 2, things are happening with the volume, but we're going to make that comparison at the end, like it asks us. They want to see what happens. What happens when the length changes. So, now that we've done the fractional parts they gave us, now they're saying, what happens when you have 2L? Well, when we have a variable next to a number, what does that mean we're going to do? Type in the comments. What are we going to do now? If L is 8 and this says 2L, right? That's the equation they're giving me, 2L. What does that mean? What am I going to do with my 2 and my 8? Go ahead and type it in the comments. Type it in the comments. Type it in the comments. Hello, hello. Oh, somebody's jumping off. There's 21 people. We should be able to... Oh, it's too hard to tell me what to do? With the 2 and an L, people are bailing out. What's 2 times L mean? Nope, I just told you. A 2 and an L next to each other means we're multiplying. Yep, thank you. Thank you, Money Mari. He's got it. Okay, so in this case, we have 2 times 8, which is, and I'll write it down, this is 2 times the length of 8. So our length is 16. To make it a fraction, I put it over 1. That's my length. 1 over 1 is my width. 3 over 2 is my height. Same thing here. I don't really want to multiply 16 times 3. Ms. Martin made me memorize some of the 16s, for when we cube stuff, but I don't want to really do that right now. I'm going to try to make this easier. So I have to look for a number on the top and a number on the bottom that I can reduce, right? So 2 goes into 2 one time. 2 goes into 16 8 times. That's a little better. So 8 times 1 is 8. 8 times 3 is 24. 1 times 1 is 1. 1 times 1 is 1. What's 24 divided by 1? What's 24 divided by 1? Thank you. Yeah, 24. And again, if this was centimeters times centimeters times centimeters, which it is, that's how I get centimeters cubed. Okay? Remember, when we have a units to a power of 1 and we're multiplying powers by each other, you're really adding the powers together. So we have centimeters cubed. Okay. So if that's what it meant for 2L, what does 3L mean? If 2L was 16, what do I get for 3L? What am I doing with that, with the 3 and the L? What operation is that? Hello? Hello? Anyone? Anyone? Thank you. Thank you, thank you, thank you. Some people are really, thank you, trying to keep their places in Avid. I like it. I like it, I like it. Yeah. It means 3 times the length. 3L means 3 times the length. So 2 times 8 was 2 times the length. 3 times 8 equals, what's Tokyo Station multiplication? I like your little rhyme. I'm not sure what that means. It's 24, thank you. So I have 24. To make 24 a fraction, I put it over a 1. That's my length. Now I have my width. Now I have my height. Again, the reason I'm using the same width and height for people that are just jumping on is because the problem told me to do that. It said, what happens to the volumes in the table when the length changes but the width and the height stay the same? That's why all the way down, I'm using 1 and 3/2 as my measurements, okay? Now again, I get to a point where I don't really want to multiply 24 times 3 because Ms. Martin told me, you know, the more things I have to do in a problem to make the numbers bigger, you know, often I can make silly mistakes. Oh, I'm crossing out the wrong number. So I'm going to use this 24 and 2 and reduce this 24. So 2 goes into 2 one time. Sorry, I was hitting that by mistake. That's still a 3. And 2 goes into 24 12 times. I know that from my 3rd grade multiplication chart, right? That we should all be practicing. Thank you. Thank you. Yep. Thank you, ladies, for knowing how to cancel those out. And then I'm just going to multiply numerators times numerators. 12 times 1 is 12. 12 times 3. I know from my multiplication tables is 36. If I don't know my 12s, I have plenty of time this summer to work on those. They're not going away. 1 times 1 is 1. 1 times 1 is 1. What's 36 divided by 1? Thank you, thank you. Yeah, 36. Anything divided by 1 is itself. Don't make this harder. So I have 36 centimeters cubed. That's bigger. It's getting bigger. As the length is getting bigger, so I'm going to start thinking about that. And then last but not least, 4L equals, what does 4L do to the length now? Go ahead, you can type it in. 4L. What am I doing with those numbers? They gave you in the problem length is 8 centimeters. Now they want you to use 4L. Go ahead and type it in the comments. Yes, it will. You can't forget this stuff. Means 4 times 8. Great. Thank you, dear. Thank you, sir. Thank you, thank you. 4 times 8. Yep, you multiply. That's the operation. When you have any number next to a variable, when we did equations and expressions in that unit, we learned they don't have to put a little x between them anymore. Now that we're doing algebra, if you have a number next to a variable, it means you multiply them together. Thank you. Great job. So 4 times 8 gives me 32. I make it a fraction, put it over 1, times the width, 1 over 1, times the height, 3 over 2. Again, for those of you tuning in late, we just got these measurements straight from the picture of the rectangular prism. 1.5 centimeters is 3/2. Oh, getting a little crazy with the video here. Same thing, I don't really want to multiply 32 times 3. I could. I'm just going to have a bigger number to divide. None of this is wrong. There's multiple ways. That's the great thing about it, because we all think of things differently. I'm going to try to reduce this 32 with the 2. Okay, 2 goes into 2 one time. 2 goes into 32. That is one that we asked you to memorize. You know, some of your 16s. So, then I have 16 times 1 is 16. And 16 times 3, again, if you don't know it, If you didn't memorize it, that's okay, because we can do it this way, the old-fashioned way. Coming back to you now. There we go. So, 16 times 1 is 16, times 3 is 48. 1 times 1 is 1, times 1 is 1. What's 48 divided by 1? Good morning, good morning. Good, still 48. Okay. It said, complete the table to see what happens when the length changes but the other dimensions remain the same. So you should have a nice, neat table that has the numbers of 8 in it. These different variations, of the length, with 8. Half of the length was 4. A third of the length was 8/3. A quarter of the length was 2. 2 times the length was 16. 3 times the length was 24. 4 times the length was 32. Right? And then we had all of our answers. 12, 6, 4, and then they went back up. So this is the second column, right? Okay, so we completed the table. Now it's asking us in part B, how did the volume change when the length was 1/3 as long? They're asking us about a specific one. Good morning, good morning. Okay, so when you made this a third, okay, now we're going to look at this row, the original row, and then this row. When we made the length a third as long, 1/3 times 8, we got 8/3. What happened to the volume? Good morning, good morning. We're on B. How did the volume change when the length was 1/3 as long? The length was 1/3 as long. The volume went from 12 to 4. Any ideas? When I had 1/3 of the length of 8, I had 8/3. If I had 1/3 of the volume of 12, sorry, this is my scratch, I would have 4. So, when I reduced the length by a third, or to a third, the volume became 1/3 as much also, right? When I took 1/3 and multiplied it by my original length, if I did the same thing and took 1/3 of 12, that's what I just did here, then my volume was 1/3 as big. So that should be an interesting note to you, that if you take 1/3 of the length and everything else stays the same, the volume is 1/3 as much. Okay, that's the change in volume. The volume was also 1/3 as much. Okay? So let's look at C then. How did the volume change when the length was tripled? Okay, so now you're comparing this part of your table. When you tripled the length, 3 times L, which started out as 8, 3 times L was 24. What was our volume when 3 times 8 was 24? our volume was 36 centimeters cubed. And what do you get when you take 3 times 12, which was the original volume? What's 3 times 12? You can type it in the comments. You can type it in the comments. 3 times 12. We took 3 times 8 and got 24 for our length. So what happened to the volume? What is 3 times 12? Centimeters cubed. Thank you, sir. 36. So the original volume was 12, right? If you multiplied it by 3, you got 36. Same with tripling the original length. Okay? So, when you tripled the length, you tripled the volume. Does that make sense? When we took 1/3 of the length, we took 1/3 of the volume. When we took 3 times the length, then that gave us 3 times the original volume. We tripled it. So, what is that relationship? What conclusion, that's what they're asking you in D, what conclusion can you make about the relationship between the volume and the length? So think about that. What conclusion can you make about the relationship between the volume and the length? You have your whole table of data. You know, we just figured all this math out. That's a lot of math, right? A lot of multiplication and division. And we just answered B and C. So you're going to have to go ahead and think about D. And again, when you take pictures, I'll expect to see your written answer there so that we can see if you were right. We answered it together, but I want to make sure that you write that out like a part question answer, right? Okay, next question. I don't know, I feel like for you this says number 4 on your paper. I don't know why mine says 3 again. I feel like there were a couple that were numbered wrong on my paper. I don't know, maybe they're wrong on your paper. But this is the next one. And we're going to get through it. So there's... Good, I like your answers. Very nice. You might want to just tighten up that answer a little bit. Make sure you have capital letters and punctuation. So instead of using whatever, you might want to give a couple examples of what operations. But I like where you're going with your answer. Good girl. So another rectangular prism. We're still doing volume. And they've made it a 6th grade problem because we have fractions, everybody's favorite, right? We have mixed numbers. That means they have fractions in them. So A says write numerical expressions to represent the volume in 2 ways and explain what each reveals. Refer back to your notes to help answer the question. Well, we always have our notes to go back to, right? You're always able to use your notes. That's why we take the notes. So, there's 2 ways that they taught us to do this. 2 different formulas is the way they're actually looking at this. So we had, and I'm just scrolling back through the notes. Don't forget there was Khan Academy videos to watch that help explain this, and you can have access to those on your phone even if you don't have computers. We have our 2 formulas, right? We have length times width times height, and we have the area of the base times the height. So that's what we're going to use, are those 2 different ways. That's what they wanted us to demonstrate. So if I have my length, who can tell me what the improper fraction is for 10 1/2? You can just type it in the comments. Okay? We're going to start with the length. What is the improper fraction for the length? Somebody can give me the improper fraction for the width. And height is just 6 inches. So I'm going to make that a fraction by having 6 over 1. Okay, so go ahead and type it in. Go ahead and type it in. Good. So we have 21. And you keep the same denominator. And what about the width? 1 2/3. What do we get as our numerator for that improper fraction? Again, we know the bottom will be the same. Thirds. What goes on top? Yep, thank you. Good job. We have 21 over 2. Good. Not 5 over 2, though. Remember, this time, you have 1 times 3 is 3, plus 2 is 5, but you have to keep the same denominator. All right, good job. So, now we're going to multiply. Anything we could cancel out from any of the top numbers with any of the bottom numbers to make it a little smaller so we don't have to multiply, 21 by anything, because I didn't learn my 21s. Anything you want to cancel out, you can just type the 2 numbers you want to cancel out in the comments. One. No, we're not going to cancel out any 1s, or numbers would stay the same. 6 and 1? No. Oh, it can be 6, but we want to keep it as a fraction. You're right, because we started with 6. We made it a fraction, though, because we want to be able to make our multiplication of fractions easier. So, I said to focus on the big number. I didn't want to multiply my 21s. So I want to reduce, 21 with my 3. 3 divided by 3 is 1. How many times does 3 go into 21? You can just type it in. 3 goes into 3 one time. 3 goes into 21. Just type it in the comments. 21 divided by 3 gives you what? What's 21 divided by 3? Thank you. 7. So, I'm going to have 7 times 5 times 6. Now remember, with the commutative property, I can multiply these numbers, these 3 numbers, 7, 5, and 6, in any order I want, and I'm going to get the same answer. So, I'm going to use the tricks we've talked about this year. I'm going to multiply 5 times 6, which is 30, because then it's easy to multiply 30 times 7, right? A lot of us can do that in our head, right? 30 times 7. So I'm going to get 210 at the top, and then I have 2 times 1 is 2, times 1 is 2. Right? I could have also cross-canceled this 6 and this 2 and made it even easier. Okay? But here I still have to do some reduction. I have to take 210, divide it by 2, or I'm not done. So, 2 goes into 2 one time. 1 times 2 is 2. 2 minus 2 is 0. 0 is smaller than my divisor. Bring down the 1. 1 divided by 2, I can't do. It's 0. 0 times 2 is 0. 1 minus 0 is 1. 1 is still smaller than my divisor. Bring down the last 0. 10 divided by 2 is 5. 5 times 2 is 10. 10 minus 10 is 0. I have 105. This middle 0, that's the hardest part, is people take the 1, they realize they can't divide 2, and they just bring down the 0 and would have like 150, 1, 5, something. So That's not how you do it. This is how you do it. So you'd have 105. The units are inches. And it's cubed. Not 100, 105. Okay? So that's one way. We could have done the length times the width times the height. Okay, the other way is doing the base times the height. So you would have taken 21 halves times 5/3. We'll do 3 goes into 3 one time. 7 times 5 is 35. 2 times 1 is 2. So this is my area of the base, because this is my length times width. So then the formula says to take the area of the base, 35 halves, and multiply it by the height. Good morning. You know, that's where I could reduce. 2 goes into 2 once, 2 goes into 6 3 times, 35 times 3. Let me guess what that is. What do you know? 105. And 1 times 1 is 1. And 105 divided by 1 is 105 inches cubed. Okay? So those are the two ways they wanted you to do that. They wanted you to explain what each reveals. You know, think about what you're multiplying together and what you're getting when you do each part, each way. Okay, so here, you know, we did it differently. We found the area of the base first and then multiplied it by the height. Okay? And then it said determine the volume of the rectangular prism. We've already done that for both. Sorry, I guess I jumped ahead a little bit with that one. Because here they just wanted the numerical expressions, which when we wrote out the problem, we started solving it right away. So, because I already knew we were doing that, but sorry, I didn't read that one to you. So, your assignment is your exit ticket. Now, people have been really lax lately about sending in their exit tickets. You're going to do this on your paper or packet, and then you're going to screenshot, good morning, your answers. So, you have this problem, determine the volume of the rectangular prism in the two ways. And another problem. Okay? This time they didn't give you the picture. So this is where you want to start, you know, kind of sketching it out yourself. Right? Thinking about it in your head. You could draw a little picture. We talked about how drawing pictures and models helps. So, on Wednesday, we will be starting day 2, which is volume in the real world. So we're going to continue to apply the formulas, but now they're going to have some irregular shapes. So your opening is your do now. So before class on Wednesday, you're going to do these problems, take a picture, and send them to me in your DMs. Okay? You're going to also be reading the new learning. Again, they're reminding you that a lot of this volume is stuff you did in 5th grade, and we're just building on it. So if you didn't learn it in 5th grade, it's really important to watch those Khan Academy videos that I've assigned. Okay? They're going to talk about the 2 different methods. So you're going to read through all that, and then we'll be doing the problems in class, and then you'll have another exit ticket. Okay? So your assignment is to do the exit ticket, get that into me as soon as possible, and make sure you do your do now for Wednesday. If you have any questions for me, there's multiple ways to get help. It's not turning around. You can, of course, people have been DMing me, emailing me. Don't forget there's After School All-Stars tutoring. Look out on the flyers for the times for that on Tuesdays, Wednesdays, and Thursdays. And there's multiple ways to get help. Ms. Mixon has her classes, so there's lots of different ways. Don't hesitate to get help if you need it. Please, please, please just ask. There's no excuses for not getting this work done. Remember, it does count. It will help you, so you need to take advantage of it. In addition to that, it matters that you know this stuff for 7th grade. So the less work you do now, the harder 7th grade will be. So please, please make sure you're staying up with your work. With all of your classes, check your grades. Those are your 3rd quarter grades. Those are not changing. And anything new goes on to 4th quarter. So I hope you have a great week. I really miss you guys. Love you and miss you. Thank you again for all the notes people sent last week. I really, really appreciate it. And I miss you a lot and hope everybody's staying well. Please stay safe. Bye.